Team faculty, Dr. Chris Peterson, and he's going to shake things up a little bit with his presentation called Using Tree Wind Damage to Improve Meteorology's EF Scale.
All right, so most of you know that I've been studying windstorm damage to trees and forests for most of my career. During that time, I've realized that the meteorological community has a problem. And that is one of their most dangerous phenomenon, tornadoes, we all know about them, are very hard to study. They're short-lived, they're very unpredictable, very hard to study in real time unless you happen to be parked in the right place with your Doppler radar pointed at the tornado. It doesn't happen very often. So as a result of that, they're forced to sort of rely on retrospective approaches to study tornadoes. One of which you've probably all heard of is the F scale, or the EF scale is the new name. This is a damage scale in which tornado wind speeds and tornado behavior is inferred based on damage to buildings or structures or, in fact, trees. This is where I come in. I can help them. So the problem is the EF scale has a number of criteria for rating tornado intensity. Most of those criteria are based on buildings. Some of them are based on trees. Unfortunately, the tree part of the EF scale is deeply flawed. It has a lot of problems, and I've been telling them this for a couple of years now. They're starting to listen, thankfully. But instead of just sitting on the sideline and complaining, I thought, how can I help them? Because I do know a little bit about trees. And the answer seemed to be help them calibrate the tree part of the EF scale. And so how do we do that? That's what I'm going to talk about here for a minute or so. And that is to go to a post-storm situation and compare side by side damage to houses, which are understood really well from an engineering standpoint. We can be pretty confident of our estimates of wind speeds based on house damage and calibrate that to the trees that are right next to the house. So here's a couple of examples. Here's a house that has EF2 damage. Here's a tree that has hardly any damage, and so that would be rated EF0. So that's sort of a problem. So these two pictures kind of illustrate the problem. The answer is to go through for a large number of houses. This is a project that's still underway. And compare the damage to houses and the trees that are right next to them, and calibrate the tree damage such that we know what the wind speed was for the house, because that's understood very well. And then we can calibrate the types of damage to the trees, so whether the tree is intact or standing or defoliated or branches broken or whatever. So this is a way that we can improve on the EF scale for the meteorological community, hopefully save some lives in the process, and make a contribution from the ecological world to the meteorological world. That's it. Thank you.